Good morning, guys. Sorry I'm not there today, but this is the lesson that we were going to go over. This is worksheet 2-2, okay? Dealing with domain and range, both graphically and algebraically. So we've started doing this. The only new thing will be on the following page, okay? So remember, domain is your x values, okay? Right? And then your range is your y values, okay? These are sometimes called your inputs, your x values, and sometimes called your outputs, your y values, okay? If we take a look here, I gave you two tables, okay? This is going to be on your homework. We didn't do this. If I'm asking for the domain of a table, you're just going to use the squiggly brackets, okay, to show that this is a set of numbers, and you're just going to list them, okay? So that would be your x values, right, domain, and then range would be your y values, right? And you don't have to repeat values, so this would just be 5 and 1, okay? And then here, they have inputs, outputs. Again, that would usually be x and y. So if you want your domain, right, it would be 0, 2, 3. And then your range would be 1, 2, 3. Usually you list it in order. It doesn't have to be, but usually it's in order, okay? And then the question is do these tables represent functions? Well, to have a function in a table, right, we talked about it graphically earlier, but in a table, the best way to describe it is every input, or x value, should have one output, or y value. All right, so every number that you were to plug into an equation, okay, or see in a table should have exactly one corresponding y value. So here, even though the y's repeat, okay, -4 corresponds to 5, right? -3 corresponds to 1. Each one of these has their own y value. It might be the same as others, but they have their own. So this is a function, okay? This one, 0, has two different outputs, okay? So if I were to plug in 0, it would give me two different answers, which is not a function, okay? If I were to graph it, the 0 would have 2 points plotted, which means it would fail the vertical line test, like we did earlier, okay? So this is no, right? So that's how you, there's also the fact that the x values, sometimes students say this too, cannot repeat is another way to look at it, right? So if you were to list all the points here, like 0, 3, 0, 2, you'd see that the 0 repeats itself in two of the coordinate pairs, okay? So therefore, this is not a function. That's another way to look at that, okay? Now, this guy, right? These are all functions we have here, okay? And we're going to see that when we go to graph them. But we haven't done much graphing, so I'm fine with you guys using your calculators right now, okay? So if we put this in our calculator, what is it, x squared, right, plus 5x, right, and we have graph. Now your window is probably messed up because we did some word problems, so you're going to want to hit zoom 6, and then you'll get the normal, right? So you should be able to see here that we have a x-intercept at 0 and a y-intercept at 5, and then we can calculate, which we'll do later on, actually finding it algebraically. Some of you know how to do this already because I saw it in your work, but we can trace and calculate the minimum here, right? So we can kind of get a good shape here. So that would be left bound, right bound, and there, and that's our minimum, right? So we're going to graph -2.5 and then -6.25. So -2.5 and then 6, 1, 2, 3, 4, 5, 6. That's about here-ish. Okay, and then our x-intercepts were 0 and 5. 1, 2, 4, 5. And that's our sketch. Okay, so we had 5, negative 5, 0, sorry. 0, 0. And then, like we said, this was negative 2.5 and negative 6.25. Okay, so that's our sketch. All right, so if we look at this, right, and we want to find, I'm asking you for domain and range. We've done this, right? The x values of a parabola, right, continue all the way left and all the way right. We can see that if we zoomed out, this would continue to increase, right, but also spread out in the x values. So for a parabola, okay, the domain is always all real numbers, right? Negative infinity to positive infinity, okay? When you were graphing these way back in Algebra 1, you never talked about domain restrictions, okay? Which we're going to talk about today. So it's all real numbers, all right? Negative infinity to positive infinity. We're going to use interval notation now, okay? And then if I look here for my range, the reason I needed my minimum, right, is to write the range. So if I look here, my y values, right, start to exist at negative 6.25 inclusive, so make sure you have a bracket, and then they increase to infinity, okay, because it's increasing there. So everyone from there all the way up, all right? That's my domain, that's my range, right? This is a function, right, because it passes the vertical line test, okay? So all are these? Yes, they're gonna all be functions, okay? Now this one is very funky. I'm just letting you know that, okay? And here's why. If you remember, we went and we solved equations that involved fractions, right? Like this, rational equations, okay? And hopefully you guys remember that there was some excluded values or a restricted domain, okay? Or extraneous solutions, all different words that we may have used to describe this. Here, the denominator, right, can't equal 0 when you're solving it. Well, when you're graphing it, it also creates problems. So here, for your domain, right, okay, we know, domain being x values, right, that x squared minus 4 cannot equal 0, right? We know that algebraically. Well, it's going to happen graphically too. So if I do this, x squared equals 4, x equals square root plus or minus 2. X cannot be plus or minus 2, all right? Algebraically, that's true, and graphically. So if I look here, and I put this into my graph because I wouldn't expect you to know what this looks like. We're going to put, let me go back, clear that guy out, 3x, and then divide by x squared minus 4. And then hit graph, and you will get this. Now, if you have a different version of the calculator, you will not see these lines. It's just because they're pixelated, those lines are not really there. Those are actually asymptotes that I talked about yesterday, right? So if you look, those asymptotes actually exist at, weirdly enough, -2 and 2, okay? And again, we're going to graph these eventually without a calculator. But if you look, there's also an asymptote here, okay? And your graph is going to look like this. This is just a sketch, right? The only thing it goes through is 0, 0 here, and it kind of looks like this. I'm not plotting really any points. I'm just sketching it. And then it looks like that. All right? So that's my general sketch. All right? If you look at the graph and you see asymptotes, that means if it curves off and doesn't touch, right, those values, then that means those are excluded values. All right? Now, if we look here, you can see in the table also, if you guys look, can you see how -2 has an error? The graph does not exist there. Okay, sorry, my shadow is making it so you guys can't see that. There we go. So my graph looks like this, right? That's what I sketched. And then if you go to your table, right, you will see an error at -2. There's my x and y intercept at 0, 0. And then 2 has an error as well. So that means that the graph doesn't exist at those points, just like we said the solution could never exist at those points earlier. So what we're going to do is we're going to exclude 2 and -2 from the domain. So if you remember, what that looks like is it's all negative values up until -2, union -2 to 2, right? So it's everything in the middle here. And then we exclude again 2. Now that's a very complicated domain, okay? But you're excluding 2 values. That's why you have 3 sets of parentheses there, okay? So that's what that is, okay? Then our range, if you look here, there is an asymptote here, but at all points, at some point, I should say, in the graph, the y values increase forever and decrease forever. So your range is -infinity to +infinity, okay? Okay, so that's a little bit harder. That's definitely a rational function. That's super important, okay? And then this guy is the other super important function, okay? A square root function. If you remember, this is when we had extraneous solutions too, right? You can't take the square root of a negative number, right? And be able to graph. So we're going to have problems here. So just like we had extraneous solutions for rational and for radical equations, we're going to have domain restrictions too, okay? So if I put this in my graph, my calculator, this is, right, we're going to put second square root. Okay, mine puts a parentheses, yours may not, depending on the model of calculator. 4 minus 3x, right? And we're going to close our parentheses and then hit graph. And we look like this. We can see that looks like it has an x-intercept of, I don't know, let's see. Can I see it? No, okay. So I can't see it, but I can see the y-intercept is 0, too. So I'm going to plot that. The x-intercept, let's see, second trace, 0, right? I can't really do this one, right? So how am I going to find this? Well, if I need the x-intercept like we've done before, right, because I can't see it on there because I can't do left bound and right bound because of the shape of the graph, what I'm going to do here is x-intercept means that y is 0. So if I do this, right, square both sides, 4 minus 3x. I don't know why I keep wanting to change that. -4 equals -3x. X is 4/3. So that is your x-intercept, right? 4/3, 0. So if we take that, so what's that? That's about here, right? And then I'm just going to take, that's all I really need, right? That's what I've stressed to you guys is the x and y intercept. That looks like my graph, okay? So therefore, if I look, right, this is, right, 0, 2, and this is 4/3, 0, okay? If I look at my domain, right, my x values start to exist at a value of 4/3. That's why it's important to find the x-intercept. So I'm going to go 4/3 to -infinity. Right, because it's decreasing. So try to put it in that order. I know a lot of you reversed it. So it starts at 4/3 and then heads to the left for domain. And then range, if you look, it starts to exist here and then it increases. So this is like my starting value. That's what I'm going to use a lot to write the range for a square root function. But this should be starting at 0 and increasing. And inclusive because we plotted that point, all right? So these are all functions, again, because of the vertical line test. You're going to want to think, right, about the x and y intercepts, all right, when you're writing domain and range, okay? But these two we're going to see now. Let's say we don't put it into our graphing calculator. What do we do? Okay, so if I give you equations like this, right, in interval notation, I want you to find the domain and range, okay? So for letter A, if we look at that guy, hopefully you could put it in your calculator, okay? But hopefully you recognize that this is going to be a parabola, right, facing up. I'm not even going to sketch it. It's just a parabola facing up, right? Because it has a positive x squared, right? So if that's a case, there are never any domain restrictions on an x squared parabola. So that means this domain, you don't have to do any work. It is literally just negative infinity to positive infinity, okay? Just like with any line, if you're graphing a line, there's no domain restrictions on that. So with a parabola or a line, same for a line, which is y equals mx plus b, there is no domain restrictions, okay? And again, you can always look at it in your graphing calculator, that's fine. Now this guy is a square root function. So this, let's star that, should make you think there's an issue here, okay? So you can't take the square root of a negative number. So algebraically, what you're gonna do is you're gonna take what's underneath the radical, right? And you're gonna always make it greater than, so whatever the expression is always going to be greater than or equal to 0, right? Never, this expression underneath should never be negative. So no negatives. So if I do this guy and make it greater than or equal to 0, I just solve, right? So this is 2x greater than or equal to negative 8. I'm doing the math in my head already. And then x should be greater than or equal to negative 4, okay? So now I want this in interval notation, right? If I do this, okay, then it should be negative 4 to infinity. Okay, that's your domain, okay? You can also put it in your calculator. So if you go back to your calculator, y equals, if we put 2x plus 8 graph, there it is. You can see it starts at 4, negative 4, and increases, right? That's my domain, okay? Now this guy, and this one, stars. So again, a parabola is easy, a line's easy. Okay, these, when we have fractions, it's harder, and when we have a radical, because of the extraneous solutions, which create domain restrictions, okay? So here, when I look at this guy, immediately, right, if we have a fraction, right, the denominator can't equal 0, okay? So I'm going to say 4x minus 3 cannot equal 0, right? So then I just solve, just like you did when you were trying to find what the excluded values were. So x cannot be 3/4, okay? So if x cannot be 3/4, right, that's the only value we're going to exclude. So it's going to go all the way from negative infinity to positive infinity, right? We're going to go up to 3/4, not include it, and then pick up right after 3/4. So that's how you exclude a value, just one, okay, in this case, all right? And then last but not least, now we have, right, a fraction again. This cannot equal 0. I don't care what happens in the numerator. The numerator never gives me a problem. But the denominator cannot equal 0. So we have x squared minus 2x plus 1 cannot equal 0. Then I think we get x minus 1 cannot equal 0. So therefore, x cannot equal 1, right? We end up with the same factor. If they were different factors, then we'd have 2 excluded values. And your domain would look like this with 3, right? Sets of parentheses with 2 excluded values, okay? But here we only have 1. So we're going to say this goes from negative infinity to positive infinity, except for 1. And that's my domain, okay? Now, if, just so you know, if you can't factor this, if it's not something you can solve for 0, then that just means there is no domain restriction, which can happen, all right? So if you try to set this equal to 0, you can't solve it, then it's all real numbers, okay? So on your homework, you're going to see some graphs, right? I ask you for a domain. You can put it in your calculator. These guys, on the second part of your homework, you're going to do this algebraically, all right? So you need to be able to show me what you know as far as algebraically, because you may not always have a calculator, all right? I hope you're all doing well, and I will see you tomorrow.